Hello everyone. In this video we are going to finish up chapter 19 with section 9.8 over ammeters and voltmeters. So your book goes into a lot of detail about analog ammeters and voltmeters and the characteristics of those and how the measurements are affected based on certain parameters. So definitely read that material, work through the couple of examples it gives in there. But what I wanted to focus on for this section is a couple of features of digital multimeters. So digital multimeters have the advantage of being highly precise. So you can measure smaller changes in voltage and current. They are also fairly accurate. The uncertainty on most multimeters is within about plus or minus 2%. And something else I wanted to point out, as you may have noticed, there are 3 posts on these multimeters. This middle post is usually the ones you guys use in lab. So this is for relatively small currents on the order of a few hundred milliamps. This top post is also a positive post, but this is for higher currents. So currents on the order of 1 amp or more. And then I also wanted to point out what the different settings within the ranges are for. So of course you have a section here that you would turn to if you want to measure voltage. You have a section you would turn to if you want to measure current, and likewise resistance. But these are subdivided, and it's a little easier to see on this graphic, into ranges. So like in the case of voltage, you have let's talk about current. So you have up to 2,000 microamps, 20 milliamps, 200 milliamps, etc. So that setting will measure up to that amount. So if you go over that amount, you will get usually a 1 and then a dash on your multimeter. That means you have exceeded the measurement limit of that setting. And so you need to go to the next highest setting. So each subdivision is only rated to measure up to a certain amount. So the other thing that I wanted to point out relates to how ammeters and voltmeters work. And so remember we talked about the internal resistance of any component. Batteries have an internal resistance. Ammeters and voltmeters also have internal resistances. And this relates directly to how they work. And so an ammeter measures current, and as you know, it is connected in series within the circuit where you want to measure the current. And so in order for current to pass through this ammeter connected in series, and to get the reading of the current at that point, the ammeter itself must have very low internal resistance. And if you think about this conceptually, this makes sense, right? Because resistance is an impedance to the flow of current. So if the ammeter had very high resistance, then the current, it would disrupt the flow of current around the circuit, and you could not get an accurate reading. Voltmeters on the other hand, remember what a voltmeter is. You're measuring a potential difference between 2 points, right? So if you want to measure the voltage drop across a resistor, then your voltmeter is connected, one lead on one side, the other lead on the other side of the resistor. So you're measuring the difference between potential at those 2 points. Now, I want to point out, if you remember from our discussion on series and parallel, when current reaches a junction, it can split and it can take one of 2 paths. Now, current takes the path of least resistance. So in order for you to get an accurate reading, the internal resistance of this voltmeter must be very high. So what this does is it keeps current from flowing into this parallel branch that we have created. And so the majority, and I'm sure there's probably still a negligible amount of current that still flows through this voltmeter, but a good estimate, most voltmeters have an internal resistance of 10 million to 100 million ohms. So that is a very, very high resistance. So the point of that is so that the current will still, all the current entering this point, 99.9999% of it will still flow through the resistor itself. So your reading, if your resistance of your voltmeter is very high, your reading of potential difference across the resistor is accurate. Okay. And so that is the main takeaway that I want you to remember in digital multimeters. So in your ammeter settings, which runs on a different circuit internally within the voltmeter or within the multimeter than your voltmeter settings, an ammeter has very low internal resistance, while a voltmeter must have very high internal resistance. So that will finish out chapter 19 for us. So remember, you have homework due this week over chapter 19 on mastering physics. And we will begin chapter 20 shortly.